All right, we've done all the cute picture stuff. Now let's learn the standard algorithm, baby! All right, let's look at standard algorithm for multiplicationing. Standard algorithm's like the greatest. You know what I'm saying? Gag me with a spoon. Let's start with 1 and 7/10 times 4/10. Now we need to think, before we begin, let's think back to what we learned in multiplication. You probably think, and maybe your teacher didn't phrase it this way, that when you're multiplying, your product is always going to be bigger than your factors, the numbers you start with here. Because if you multiply 1, let's say we multiply 10 times 1, I get 10. If I multiply by 10 times something bigger than 1, my answer, my product, is going to be bigger than 10. However, I am multiplying by something less than 1. And since I am multiplying by something less than 1, I'm going to make this factor smaller. My product has to be smaller than 1 and 7/10 because I'm multiplying by less than 1. Okay, let's start with estimating because our steps over here, estimate the product. Product is the answer to a multiplication problem. Multiply without the decimals, and then use the estimate to place the decimals. You've hated estimating. He's been making us do it for 9 weeks. Why do we have to keep doing it? Because I said so and because you need it. First of all, I have 1 and 7/10 multiplied by 4/10. Let's think about it. I know my answer is going to be less than 1 and 7/10. Is 4/10 less than or greater than a half? Good, it's less than. My answer is going to be less than half of 1 and 7/10. So I know it's going to be less than half of 1 and 7/10. And half of 2 would be 1. So half of 1 and 7/10 is going to be less than 1. So let's take our second step. It says to multiply without the decimals. So I'm going to multiply 17 times 4. I don't need to put that 0 in there. I'm just multiplying 17 times 4. I do not want to see, when you do this, to have the decimal point there, have a 0 in the decimal point there, because that's going to be crazy. Now we just multiply like normal. 7 ones times 4 ones is 28 ones. 4 times 110 is 4 plus 4, 40, plus 2 more is 42. Now I said my answer had to be less, let's see, 28, 8, 2, 4, 5, 6. Had to be less than half of 1 and 7/10. So my answer is actually going to be less than 1. Okay, if I put it here, my answer is 4. It's more than 4. If I put it here, my answer is more than 42. If I put it here, my answer is 428. So that's the only way I could possibly do it. All right, we're going to look at 1 and 8/10 times 30 and 2/10. Standard algorithm. First, I'm going to estimate the product or estimate the answer to my multiplication problem. I don't have to be exact. But if I say 2 times 30, my answer is going to be somewhere around 60. You're saying you start with 30, you multiply it by 1, and you're going to get something around 60. Well, second step says multiply without the decimal points. So I would multiply 302 times 18. I'd always put my one with the more digits at the top. That's just easier. I see some of y'all doing it the other way around, and it's cray-cray. 2 times 8 is 16. Add these together, 6, 3, 4, 5. My estimate says it's 60. I have to use that estimate to place the decimal point. If I put my decimal point here, my answer is 5,436, not close to 60. If I put my decimal point here, the answer is 543 and 6/10. Not close to my estimate. If I put my decimal point here, it's 54 and 36/100. It's pretty close to 60. If I put it here, it'd be just a little bit more than 5. And if I put it here, it would be less than 1. So the only place that gets close to our estimate is if I make it 54 and 36/100. We have 13 times 9/10. We're going to do our estimate. So 13 times 9/10 is close to 1. So if I say 13 times 1, my answer is going to be near 13. Is it going to be more than 13 or less than 13? Well, let's think about it. If I multiplied 13 times 1, my answer would be 13. Easy. This is less than 1. So if I'm multiplying by less than 1, my answer is going to be smaller than 13. So if your product is 13, you don't have it right. If your product is greater than 13, you don't have it right. Because we're multiplying by less than 1, and since we're multiplying by less than 1, that means my answer is going to be smaller than 13. So, like the steps say, I estimated. Now I'm going to multiply without the decimals. So I have 13 multiplied by 9. No decimal points. I just multiply without the decimals. 9 times 3 is 27. 9, 10, 11. My answer has to be close to 13. If I put my decimal point here, the answer is 117. If I put my decimal point here, it's 11 and 7/10. If I put my decimal point here, it's 1 and 17/100. If I put my decimal point here, it is less than 1. The only one that is close to 13 is 11 and 7/10. Five times 41/100. We need to estimate. So I'm going to keep 5, obviously, as it is. I can count by 5s. Times, now this is less than 1, so my answer is going to be less than 5. It's less than a half, because 5/10 would be a half. And so if I was multiplying 5 times 5/10, it'd be 2.5. So I'm going to get an answer less than 2 and 5/10. My answer is going to be less than 2 and 5/10. Okay, not a whole lot, but less than 2 and 5/10. I multiply without the decimals. So then I have 41 times 5. It's 20. If I put my decimal point here, it's 205. If I put it here, it's 20 and 5/10. If I put it here, it's 2 and 5/100. If I put it here, it's less than 1. So obviously, it has to go there. Find the product of 18 and 3/10 and 1 and 6/10. If I estimate, I have 18 times 1, so my answer is going to be somewhere near 18. Somewhere near 18. I can make it 18 times 2 and 36, so my answer is between 18 and 36. We estimated, now we multiply without the decimals, so I have 183 times 16. 3 times 6 is 18. 6 times 8 is 48, plus 1 is 49. 6 times 1 is 6, plus 4 is 10. I'm moving over to the tens place, so then I have a 3, an 8, and a 1. I add these together. So I have 2928. My answer cannot be 2,928. My answer cannot be 292 and 8/10, 29 and 28/100, 2 and 928 thousandths, or less than 1. Well, the only one that falls in my range of my estimate is 29 and 28/100. Now you got it. You can multiply decimals using the standard algorithm. I always believed in you.